Today, we are formally presenting the full white paper of the Human Knowledge Ledger, HKL. This document, titled The Human Knowledge Ledger, a verifiable, transparent, and durable infrastructure for global scientific knowledge, was published as version 1.0, December 2025, authored by Griffin at TaBIS, Technology and Business Innovation Studio. This video publicly displays the entire white paper in full. It serves as a time-stamped disclosure of the conceptual and architectural framework of HKL. HKL is not a journal. It is not a token project. It is not a speculative crypto mechanism. HKL is a proposed complementary infrastructure layer for global scientific publishing. As described in the abstract of the white paper, modern science operates at unprecedented scale. Research output grows exponentially. Artificial intelligence increasingly participates in analysis and discovery. Data volumes are massive. Collaboration is global. Yet the infrastructure that records, evaluates, and preserves scientific knowledge has not structurally evolved. HKL begins from a simple premise. Scientific knowledge requires durable provenance, transparent evaluation, and long-term preservation independent of institutional fragility. The white paper outlines the structural limitations of the current publishing ecosystem: opaque pre-publication peer review, gatekeeping barriers that exclude independent researchers, reviewer labor uncompensated while publishers extract value, publicly funded research locked behind paywalls, fragmented version control, centralized preservation risks, and most critically, the emerging epistemic instability in the AI era. One of the central arguments in the introduction is the concept of knowledge collapse. When AI systems train on synthetic outputs without grounding, signal degrades. Rare knowledge disappears, distortions accumulate. Science itself risks a similar dynamic. When evaluation is hidden, corrections are detached, and provenance is fragmented, the integrity of knowledge erodes gradually and invisibly. HKL proposes structural countermeasures. The architecture is intentionally modular and minimal. 3 primary layers are defined. First, the verification layer, on-chain, lightweight, cryptographic. It stores only hashes, timestamps, identity bindings, and evaluation anchors. No full content is placed on-chain. This ensures durability without bloat. Second, the knowledge storage and access layer, off-chain, distributed, content-addressed, manuscripts, datasets, code, replication packages, all stored in decentralized systems like IPFS or institutional repositories. Version histories are preserved. Nothing is overwritten. Third, the evaluation and reputation layers. HKL separates publication from evaluation. Authors may publish without gatekeeping. Evaluation then occurs transparently, post-publication, signed by reviewers. Reviews themselves become first-class artifacts. This transforms peer review from a hidden editorial filter into an open scientific process. A structured reputation framework, impact-indexed reputation or IIR, accumulates signals across evaluations, replications, corrections, methodological audits, usage and influence networks. Importantly, IIR is not a single metric. It is a multidimensional graph designed to remain machine-readable. This is critical for the AI era. AI systems require structured, version-aware, provenance-rich corpora to avoid amplifying outdated or flawed research. HKL is designed as epistemic infrastructure, not as a publishing company. The governance section makes this explicit. Governance cannot delete works, cannot censor scientific claims, cannot override evaluation outcomes. It exists only to protect protocol integrity, neutrality, and long-term sustainability. The system also introduces a hybrid reviewer incentive model. Reviewers gain reputation through IIR. Optional financial compensation mechanisms can exist without token speculation or securities risk. The protocol explicitly avoids financial instruments, token fundraising, or speculative economics. HKL is architected conservatively, legally, ethically, and technologically. Appendices define metadata schemas, provenance chains, evaluation objects, and identity bindings. Everything is structured for interoperability with DOI, ORCID, ROR, Crossref, institutional repositories, and AI tooling. This white paper is not an implementation document. It is a conceptual and architectural framework. Operational policies, governance processes, and implementation layers would evolve through community participation. The purpose of this publication is to formally disclose the system-level design. HKL is grounded in several philosophical commitments: knowledge as a public good, the right to contribute without institutional gatekeeping, transparent and accountable evaluation, durability across generations, neutrality and resistance to capture, human-AI coexistence in scientific reasoning. This is not an incremental improvement proposal. It is infrastructure thinking. Scientific publishing has evolved in layers across centuries: printing presses, scholarly societies, digital repositories, preprint servers. HKL proposes the next layer: a verifiable, transparent, machine-readable ledger of scientific provenance and evaluation. The vision and conclusion section states clearly: HKL does not replace journals. Journals become curators rather than gatekeepers. HKL becomes the structural substrate beneath them. This video serves as a public declaration of authorship and invention of the HKL framework. The full white paper is available. The complete architecture is disclosed. All conceptual claims are timestamped by this publication. HKL invites researchers, institutions, funding agencies, journals, infrastructure builders, and AI system designers to engage. The work of building resilient knowledge systems cannot wait for institutional inertia to resolve itself. Science deserves infrastructure that matches its scale. This is version 1.0. It marks the beginning. The responsibility of preserving knowledge spans generations. The work starts now.